Hi everyone, this is Mrs. Snowbeck. Today we're going to do some quadratic review. We're going to review foiling, factoring, and the quadratic formula. So foiling, some of you might have learned it as the box method, and some of you might have learned it as foiling. It kind of depends if you had geometry at Farmington High School or at one of the middle schools. But what FOIL stands for is firsts, outsides, insides, and lasts. And basically, when you multiply two binomials, like you see here in example 1, this is a binomial because it has two terms, and this is a binomial because it has two terms. When you multiply two binomials, you have to do a thing called FOIL. And so we start by multiplying the firsts. F stands for firsts. It's the first thing in each parenthesis. So x times x is x squared. Then we do the outsides. The outsides are in the front and the back. And so we're going to multiply x times -6, -6x. Then we're going to do the insides, which are going to be the 7 and the x. So that's 7x. And then we're going to do the lasts. And the lasts are the last two things in each parenthesis. So 7 and -6. Multiply those, you get -42. Lastly, we're going to combine our like terms, and so we wind up with x squared plus x minus 42, and that is our answer. Notice our answer is a trinomial, and it's quadratic because its highest exponent is a squared, or a 2. So that's how I know it's a quadratic. Now, some of you might have learned it a different way. You might have used what's called the box method, and so I'm going to do that here too. So let's put x plus 7 across the top and x minus 6 across the bottom. So you take your two binomials and you just kind of spread them out over the box. Now x times x is x squared, x times 7 is 7x, x times -6 is -6x, and -6 times 7 is -42. Notice we got the same four things, which still, if we combine our like terms, still get us to the same answer. I don't care which method you use. You can use FOIL or box method, but as you get higher up in math, most people use FOIL. It's just quicker than drawing out the box. Will you guys please try number 2? So pause the video, give it a try. So I do firsts, x times x is x squared. I do outsides, which is x times -7. I do insides, which is 5 times x, and I do lasts, which is 5 times -7. Combine your like terms, and so we have x squared minus 2x minus 35. Now we're going to take a trinomial and we're going to try to factor it into two binomials. So it's like the reverse of foiling. It's called factoring. And so I make my two empty parentheses and I think about what times what gives me x squared. Well, x times x, right? And then I have to think about what times what gives me -15. So I'm going to just use this x over here. If you had your algebra class at the high school last year, they might have called this the x factor. So I'm trying to think of two numbers that multiply to be -15, but they have to add to be 2. So I'm thinking of the numbers 3 and 5. 3 and 5 multiply to be 15, and if I need them to add to be 2, what if I make the 3 a negative? Now try multiplying those. Do they multiply to be -15? Yep. Do they add to be +2? Yes, they do. So in one of the parentheses, I'm going to put a -3, and in one of the parentheses, I'm going to put a +5. And that is it. We have factored this trinomial into two binomials. So please pause the video and try number 4. See if you can factor this trinomial into two binomials to start. And then at the end, I'll show you what it means by find the zeros. So we started the same way that we did last time, except it has an equals 0 at the back. But I want to think about what times what gives us x squared. Well, x times x gives us x squared. But now I have to think of two numbers that multiply to be negative 96 and add to be positive 20. And this might take a little while, like you might have to actually think about it. Some people make a t-chart. Some people make like, okay, what are some things that multiply to be 96 and add to be 20? Let's see, well, 1 and 96, 2 and 48, 3 and 32, I think, 4 and 24. I don't think 5 goes into it. Let's see, does 6 go into it? Yeah, I think 16. I don't think 7 goes into it. 8 and 12. 9, I don't think goes in. 10, 11. Yeah, I think we're there. And then we hit 12, which we already have. So it's got to be one of these combinations. So look at the ones. Which ones? These are all the things that multiply to be 96. Do any of them combine to be 20 if you add or subtract? Well, I'm kind of seeing these two. What if I have a positive 24 and a negative 4? Would those multiply to be negative 96? Yeah, I think so. Do they add to be 20? Yeah, so in one of these I'm going to put a plus 24, and in one of them I'm going to put a minus 4. Now you have factored it, right? But now we have to find the zeros. And I don't know if you remember doing this last year. It's basically you take the first parenthesis and set it equal to 0, and the second parenthesis and set it to equal to 0, and then you solve each of them. So for the first one, I would minus 24, and I get x equals negative 24. And for the second one, I would add 4, and I get x equals 4. So my two solutions are negative 24, positive 4. Notice it's actually the opposite of what we had up here when we factored. We had positive 24, but our answer was negative 24. And we had positive negative 4, but our answer was positive 4. You might be trying to remember, like, when did we use this? What was this about? It was when you did the unit on parabolas. Remember, parabolas look like the shape of a U, and the zeros were like where the parabola crossed the x-axis. They were your zeros. So one of our zeros would have been at negative 24, and one of them would have been at 4. That's kind of what you just figured out. You don't really have to know anything about parabolas for geometry. I was just sort of reminding you of where that came from. But you do need to know how to factor and find the zeros. Let's try number 5. So number 5 says solve the equation. That's just another way of saying find the zeros. But before we can find the zeros, we have to have a 0 on one side of the equation. And so to do that, I'm going to start by adding 16x to both sides. That way over here, I get a 0. But on the left side, are any of those like terms? Can I combine any of those? The answer is no. You just have to list them all out because none of them are like terms. One has an x squared, one has an x, and then one doesn't have anything. Now it looks kind of like the problem we started with in number 4. Now we make our two empty parentheses, and we have to think about, I'll just make my little x over here. I have to think about what multiplies to be 15, but adds to be 16. And again, you can make like a little t-chart if you want. So 1 and 15, 2 doesn't work, 3 and 5. And I think that's it. I think those are the only combinations that multiply to be 15. So I think it's going to be this one, because if I use 1 and 15, if I multiply those, I get 15. And if I add them, I get 16. So in the front, I'm going to have x, so it's going to be x plus 1. And then in the other, it's going to be x plus 15. Now remember, to find the zeros, it's really just the opposites of whatever you have. So x is either going to be negative 1 or x is going to be negative 15. Those are the two solutions that would balance out this equation. You could check it. Like if you plug in a -1 into this original equation, you could see if your equation balances. And then plug in a -15 and see if it balances. They would be the solutions to that equation. The last thing we're going to talk about is the quadratic formula. Now there's really two ways to solve quadratics. One was to factor, like we just did. We could factor the trinomial and figure out the solutions. Well, another way is to use the quadratic formula. So sometimes when there's a number in front of your x squared, like here there's a 6, sometimes it gets quite difficult to factor. Or sometimes you run into a quadratic that just doesn't factor. Nothing goes into, the number. You can't figure out two numbers that work. Well, it's probably because they're decimals or fractions or something like that. And so sometimes it's easier to use the quadratic formula. And what I would say is for geometry, when you see a coefficient in front of the x squared, when you see something like the 6 here, I just go straight to the quadratic formula. Now, notice the quadratic formula. You might know this too, and it goes a little something like this. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. That's how I remember it. A little tune. That's going to be stuck in your head now. I'll test you on that tune in class. Just kidding. Anyways, notice the equation has a's, b's, and c's. Well, the a comes in front of the x squared. The b comes in front of the x, and the c comes as the constant back there. So it's ax squared plus bx plus c equals 0. Now remember, your a is in front of the x squared, your b is in front of the x, and your c is the number that's back by itself. So here we go. We're going to write out our quadratic formula. So again, in our case, our a is 6, our b is 1, and our c is -2. So we're going to go x equals -1 plus or minus the square root of 1 squared minus 4 times 6 times -2 all over 2 times 6. Okay, so now we simplify. And I always simplify this stuff under the radical. So I'm going to go, I'll leave that -1 alone. I'll leave the plus or minus alone. Under the square root, there's a 1 squared, which is 1, and then 4 times 6 times 2 is 48. But notice how there's two negatives. There's a negative here and here. So two negatives are going to make a positive. And so this is going to be plus 48. And then all over 2 times 6, which is 12. I'm just going to shorten up my thing here so I have more room. Okay. Now, let's keep going. So it's going to be -1 plus or minus, and under the square root, we can put 49 divided by 12. Now, the square root of 49 is 7. So it's really -1 plus or minus 7 over 12. And here's where you break it apart. You break it into the plus and the minus. So I'm going to do -1 plus 7 divided by 12 and -1 minus 7 divided by 12. I do the plus and the minus. Up on top, I get 6 over 12, which is 1/2. And on the bottom, I get -8 over 12, which is, let's see, -2/3. And so my two solutions are 1/2, x equals 1/2, and x equals -2/3. Pretty cool. Hopefully you remember that a little bit from last year. Next, you're going to do worksheet quadratic review. If you have questions, just ask. Have a great day.